So let us write a menu-driven C program for the matrices. So first I will show a program for one of the matrix, then I will show you how changes can be made in the same program for making a program for other matrices. So what my program is going to do is, it's a menu-driven program. So first option is creating a matrix. Second one is getting a particular element at a given index. Then set is for changing an element at a given index. Then displaying that matrix. So let us write a program first for diagonal matrix. So I will write a complete program for diagonal matrix. So here is the starting point, that is main function. What are the variables I need? So initially I will take few variables. Later on, if required, I will add more variables. So first of all, I need an array for storing the elements. So for that, I will take a pointer, integer star a, because I don't know how many elements are there. So I'll take the dimension, then I will create an array dynamically. So I am taking a pointer. Then n is the dimension. So diagonal matrix is a square matrix, so we need n cross n, so just one value n is sufficient. Then for choice, I may need some variable ch for choice, taking choice 1, 2 or 3 or 4. Then I need some variable maybe for reading the value, so I'll take one more extra variable x if at all required. The first thing, program should ask what is the dimension and create an array. So let us write a message, printf enter dimension, and scanf take the dimension in n, ampersand n. So here we got the dimension. Now next thing, I should create an array in a heap and assign to a. So a assign. How to create an array in heap? Malloc function, malloc. So what should be the size of an array? Size of an array for a diagonal matrix is n. Whatever the dimension is, that many elements are there. So n elements are there, only n elements in a diagonal. So n into size of integer, because this is an integer array, so size of int. So this may be a 2-byte integer or 4-byte integer, whatever the size of an integer is, that size is taken. And I should typecast the pointer of type int. So this will create a array in heap for this size n. So using malloc, we can allocate the memory in a heap. This is in C language, but in C++, a simple operator is given, that is new, for creating an array in a heap. Like we can simply say a assign new integer array of size n. So instead of this lengthy syntax, we can allocate a heap memory like this. So next time onwards, I may not be using malloc function for creating anything in a heap. I'll be using new. This is simple. Though while writing the program, I will be using malloc function, but for explanation on board, I will be writing new. Now next thing, program should display a menu, and that menu should be repeatedly available. So let us write down this whole code in a loop, that is do while loop. In the beginning, it should display the menu. So I will say display menu. So using printf, we can display this one. So 5 to 6 statements I require for displaying the menu. So I am not writing that code. Then after taking the menu option may be 1, 2 or anything. So that can be processed in switch case. Switch based on the choice that is given. The choice, whatever the choice, suppose we are taking in ch. Then if case 1 is create an array. So creating an array means I should take all the elements and fill those elements in an array. So if I show you diagrammatically, we have a pointer a and to which an array is created and attached to it. Suppose the dimension is 5, so we have an array of size 5 held by a pointer. So this array has to be filled. So in a diagonal matrix, how many elements are there? Just n elements are there. So I have to take all the elements one by one and fill them in this array. So shall we take the 0 elements also or only non-zero elements? We should take only non-zero elements, and it is obvious that we have to enter them row by row, means all the elements in a diagonal. That is the first element, the next element, the next, the next. So in the same order it should be filled. So for simply reading n values, so I will take I starting from 1, I is less than equal to n, I plus plus. See, in the matrices, we were saying that the indices are starting from 1 onward. So that's why I am taking from 1 to n. So the indices will be 1 to 5. Row numbers will be 1 to 5, column numbers will be from 1 to 5. But the array indices starts from 0 onwards. Anyway, we know this formula, that is I minus 1. There we have to save it. So we can say scanf percentile d ampersand a of I minus 1. So the first row element will be filled in this one, then next row here, next row here. So all these elements will be filled. So it will be reading 5 elements and storing them in a single dimension array of size 5. This is for creating an array. I did not write any message here. I can write a message, enter the elements row by row. Or I can say enter all the elements in a diagonal one by one. Then I can read all these values. So this is first case, that is taking the values. Now second case, getting a value from a given index. So here I can say printf enter indices. Then scanf percentile d, I should read I and j. Row number and column number, both I should read. Then after reading this one, if I is equal to j, then for this there is a non-zero element available. So in the same line I will say printf percentile d. Which element I should print? I should print an element from I minus 1. That's it. Else that element is 0. So I will print just 0. So whatever the element you want to retrieve from that two-dimensional matrix, you can mention indices. If it is a diagonal index, then we get a non-zero elements. If it is not a diagonal index, then we will get a element 0. So 2 cases are over. Now there is no space, so I'll continue here. Case 3, that is for setting an element at a given index. So I have to take 3 things: row number, column number, and element also. So printf enter row, column, and element. I will read 3 things: scanf percentile d, ampersand I, ampersand j, ampersand x. So I'll be reading 3 values. Then if the indices are for diagonal, then you change the element, otherwise don't do anything. So here I will write down the condition: if I is equal to j, then in the same line I will continue, set the element at I minus 1 as the given element x. So suppose I want to change this element or this element. So whatever the element is already present there, suppose 6 was there and I want to change it to 10, so you can change it. So this is a row 1, row 2, row 3. So I have to give row 3. So it is I minus 1. So at a 2 it will change. This is for case 3. Then break. Then the last option, display. Displaying the complete diagonal matrix. I want to display it as a matrix only, that is 2-dimensional. So for a 2-dimensional, I have to use 2 nested for loops. So let us write case 4. So first for loop, for I assign 1, I is less than equal to n, I plus plus. And for j assign 1, j is less than or equal to n, j plus plus. So I have 2 for loops. Then inside this, I should print an element only if it is a diagonal element. Otherwise, I should print a 0. So here I will write on the code for that one. So I have written complete code for displaying am displaying an element if I is equal to j, otherwise I am printing 0. Then after every row, this is slash n, that is a new line. Then the next thing is I have started with a do, then I should close it here with a while. So there is no space, so we will see this when we write the program. So here we are getting the idea how we should write a program. Explanation of a program I am doing here. So this is for diagonal matrix. So in a diagonal matrix we have created an array and reading an array and getting the value and setting the value and printing a matrix. Now we have finished for diagonal matrix. What about lower triangular matrix? We have different formulas for row major representation and column major representation. Different formulas are there. Now the program will be similar only. We want to create an array of required size, and then program will be having these 4 options: creating an array and filling the elements, then getting an element, setting an element, and displaying a matrix. So same options I want to provide. Now for lower triangular also, I want to provide same options in a program. So the working of a program will be same, but it will be for lower triangular matrix. So in a lower triangular matrix, there are 2 formulas, row major and column major. So if we take row major formula, then here the formulas will change. So in the same program, as we have already seen the program, what are the changes I should make in this one so that it becomes a program for lower triangular matrix using row major formula. So I'll simply make the changes in the program. Main function as it is, and also I was using variables like I and j, so I will declare them. Now take the dimension n. For a lower triangular matrix, how many non-zero elements will be there? If you remember, it will contain n into n plus 1 by 2 number of elements. So this size of an array which is created, I'll remove this one and I will write a C++ code here. New int of size n into n plus 1 by 2. That's all. So the size is different. Array size is different. That is n into n plus 1 by 2. Then here a menu is displayed. Then the switch case, first choice, creating a array means entering all the elements. So after creating an array, then inside the menu, here I have to read the elements. So for reading the elements, I can read all the elements 0 as well as non-zero and store only non-zero elements. So for that, I have to write on the code. So this I'll be showing while writing the program. So I have to write 2 for loops and take the elements. If the element is non-zero, then using the formula, I should store the element. And if it is 0, just I should skip it. Then get function, get, I want to get the element. So when I can give an element, if I is greater than or equal to j, then it is lower triangular element, that is non-zero element. If I is greater than or equal to j, then we have an element. So from where I should take an element? I should take an element from I into I minus 1 by 2 plus j minus 1. I'll remove this one. So from this place, that is I am using the formula. By using the formula, we can retrieve an element, get an element from a given index. Then if you want to change an element at a given index, then this is for set. Then here also, if I is greater than or equal to j, then from where I should change the value? So I should change the value at I into I minus 1 by 2 plus j minus 1 assign x. This is how I can change the value. Then for display, whenever I is greater than or equal to j, we will get an element, and again here the formula will be I into I minus 1 by 2 plus j minus 1. That same formula. So you can see that by changing the formulas at few places, the program changes for lower triangular matrix. So I have shown only for row major. Now same way we can implement for column major and also upper triangular and 2 methods, and finally for symmetric matrix and other matrices also, tridiagonal and toplets matrix. So for all the matrices, we will follow same approach. So I have given you the idea how a program should work. Now based on the same idea, I will be writing the program.